In this lesson, we will explore the cross product. In a previous lesson, we looked at what was called the dot product, and we actually used the symbol of a dot, and remember that was a scalar and not a vector. So what is the cross product? Where we're actually going to use the symbol of the little x, and the cross product is a vector that is orthogonal, remember that means perpendicular, to the plane of v and u, demonstrated in this picture. If you are in a physics class, you may have talked about what's called the right-hand rule. Whether you're in a physics class or not, I would encourage you to maybe Google the right-hand rule and see if you can find some videos or explanations of what that might be. Well, let's define the cross product. If we're given two vectors, v and u, the cross product is this fun-filled formula. Looks pretty scary. I've been teaching for over 30 years and I don't think I've ever used that formula, because why would you memorize it when we can use some different methods that is much easier. So we're going to go through the two different methods, and then you choose which one you are most comfortable with. So for example 1, we're going to be finding the cross product of v and w, and we're not going to be looking at that. So the first option is to find the cross product using what's called determinants. What is a determinant? It is rows and columns of numbers that's usually associated with a matrix. It is always square in that it has as many rows as columns. So we have a 2 by 2 determinant here, and we want to evaluate that. How do we do that? Really easy. We want to multiply on the down diagonal. We want to multiply on the up diagonal, and then we're going to subtract down minus up. And so the value of this 2 by 2 determinant is just 5. Right? So looking at the diagonals. However, our cross product involves something a little bit bigger than that. We have to look at what's called a 3 by 3 determinant. How do we set that up? Well, the first row is I, j, and k. Remember, those are our unit vectors in the direction of x, y, and z. Then the next row, because this is not commutative, order does matter, and we want to find v cross w. So the v comes first. Notice, look at the components. -1, 3, 2, that goes in this row. And then we have the components of w that goes in this row. So how would we evaluate that determinant? Or in other words, how are we going to find the cross product using the determinant? Well, first of all, it kind of helps if you have some magic erasers, but we want to look at the I, so we want to cross out the row and column that I is in, or maybe highlight it like I did. And so I want I multiplied by the 2 by 2 determinant that's left. So that's 3, 2, -2, -1. Those are the numbers that are not highlighted. Now, with my magic eraser, I'm going to get rid of that highlighting. And the next thing I want to do is J. So I want to highlight the row and column that J is in. And just because of the rules, we want to do minus J. So we have plus, minus, and then we're going to have plus, and then we're going to write out the determinant of the numbers in the order that's left. So you can see -1, 3, 2, -1. Then I need to do plus k. So again, I'm going to erase that, a little bit easier on the computer, and I'm going to highlight the row and column that k is in, and then I'm going to write down those numbers in that order. So first of all, I want to notice that this is plus, minus, plus. And now we're going to do each determinant. Okay? So we want to multiply on the down diagonal, multiply on the up diagonal, multiply on the down, up, down, up. So real easy to make a mistake because you're just multiplying. Right, so what do we have left? We have I, and then we have down minus the up. Oops. Then we have down minus the up. down minus up. And then we just need to do that arithmetic. So let's see, that's negative 3 plus 4, so that's 1i. This is negative 5, and that's negative would be positive 5j. And this is negative 7k. So that's the process of using determinants. You might want to rewind the video and watch that one more time. So option 2 is using diagonals. So the first thing we're going to do is we're going to recopy the first column, then the second column. Leave yourself some space, try to line them up because we're going to be using the diagonals. Right, so you have to be really careful. I would use a lighter colored pencil because sometimes when you're using the same writing instrument as what you wrote the problem, you lose negative signs. So be very careful. You can also do it mentally. You don't actually have to draw these diagonals. Right, so we have that diagonal, that diagonal, that diagonal. Right, so these are the downs, so we're going to multiply. So we have negative 3i plus 6j plus 2k. Now we're going to do the up diagonals. Here, here, and here. And again we're multiplying. So we have 9k minus 4i plus j. Checking your signs. So we want the down minus the up. So we have negative 3i plus 6j plus 2k minus the up ones. You want to make sure you get that distributed, and also notice that the ijk's are not in the same order as the downs and the ups, so just be careful. So let's do the I. So we have negative 3i and a minus 4i, so that's going to be positive 1i. Then we have 6j and 1j, but remember we have to have a minus, so that's positive 5j. And then our k's, 2k minus 9k is negative 7k. Is that the same answer we just got by using determinants? Yes, it is. A lot of people like diagonals, a lot of people like determinants. It's your choice. Just choose the one method that you're comfortable with. So let's look at this example. Given three vectors, u, v, and w, we want to find u cross v dotted with w. All right? So parentheses, order matters, we're going to do that first. Order of operations, remember that's going to be a vector. And then we're going to be dotting with another vector. So what does a dot product give us? A scalar. So our final answer is not a vector, it's going to be just a number. So let's set up our cross product. So either way, you have to write the 3 by 3 determinant. So it starts with I, J, K. Order matters, so I want U first. So I put those numbers, 2, negative 3, 1. Then V. Okay. So I'm going to choose the diagonal method. Being very careful, I hope. All right, so I'm going to do the downs and multiply. So I have negative 6i minus 3j plus 6k. Then I'm going to do my up diagonals. So it's a 9k plus 3i plus 4j. So here are my downs. And I want to subtract the ups. Again, being very careful to distribute that. So I like them in the correct order, I, J, K. All right, so we have negative 6i minus 3i, so that's negative 9i. Then we have the j's, so we have minus 3j and a minus 4j, so that's minus 7j. And then the k's. Okay, so that is equal to u cross v. All right, so we have u, which is negative 9i minus 7j minus 3k, and I want to now dot it with w. So now we have to remember how to find the dot product. And I'm sorry, this is not u, this is u cross v. That's what that equals to. So I want to dot those two vectors. So u cross v dotted with w, the dot product. Remember, we're going to multiply the I components, and then we're going to add the product of the j components, and add the product of the k components. And just adding that together, we get the number negative 25, which is indeed a scalar because I had a dot product. Now, if you want to see that cross product with determinants, let's do that. So if you want to see the u cross v using the determinants, all right, so we set it up the same way. Set up your ijk. Your first row has the components of u, the next row components of v. So we have I times its determinant minus j times its determinant plus k times its determinant. Remember, it's plus minus plus. All right, so for I, you cross out the row and column that I is in, and you write down the corresponding numbers in the correct order. Then for j, and again, you'll get used to doing that mentally, but if you need to cross it out, go ahead. And again, make sure those numbers are in the correct order. And then k. So here we go. We want to go down and up, down and up, down and up. So this is going to be, remember, down minus up. Negative 6 minus 3 is negative 9. Then we have 4 minus a minus 3, though that's 7. We have 6 minus 9 is negative 3. So we would have negative 9i minus 7j minus 3k. Is that the same that we got before? Yes, it is. It's right there. And so these do match. Again, pick the method that you like and that you are good at.